Alrighty, in today's video, we're going to be talking about 2.5, rational equations in one variable. We've seen a little bit about this when we learned how to simplify rational expressions, and we've seen a little bit in this in other sections to get rid of fractions, what we can do um, to get rid of the fraction. It's when it's just like the denominator is a number. This one's a little bit more in what happens if the denominator is more like a polynomial. How do we get rid of the fraction so that we can have simple equations to solve, like a linear or quadratic or so on and so on. All right. There's really good examples in the book that you can utilize as well. I'm going to give you my examples. I actually have three examples that are not in the book that I want to give. And then we'll go through some in the book. Mainly, the reason I'm giving these three examples, looking at y'all's homework, what's on the homework is actually way easier than what is in the book. And the book doesn't have easier rational equations. So I want to make sure I give you some easy ones so that you still can solve those too. All right. So the first example I have here, example one, we'll call it, is x minus 5 over 6x equals x plus 2 over 7x. All right, so when you have a fraction equal to a fraction, this is almost like doing a proportion where you have to cross multiply and divide. We're going to really stick with the cross multiplication part. And just to give you an idea on what that cross multiplication looks like, I'm going to be multiplying both sides by both denominators technically. So when I'm over here and I multiply by 6x, and I'm over here and I multiply by 7x, you're taught that that's just cross multiplication. What's really happening is if I multiply by 6x over here, I also have to multiply by 6x over here. And if I multiply by 7x over here, I would also have to multiply by 7x over here. So what you do to one side, you have to do to the other. So we just don't teach it that way because what happens is the 6x will cancel and the 7x will cancel, and you're left with still just cross multiplying. But I want to make sure y'all see what the actual math is happening because when we go through these type of questions, this is what you need to do is you have to multiply by what we call the least common denominator to be able to get rid of the denominators. And the least common denominator in this situation is 6x times 7x. There's not much more we can simplify there. So therefore, that's why we do what we do. All right. So it's not just cross multiply and divide. There's more to it mathematically. All right. So then I'm going to bring down the 7x times x minus 5. And that's going to equal the 6x times x plus 2. Notice I put now the binomial in parentheses and took the monomial out so that I could take the 7x and the 6x and distribute them to get rid of the parentheses. So 7x times x gives me 7x squared. 7x times negative 5 gives me negative 35x. 6x times x gives me 6x squared. And 6x times 2 gives me 12x. At this point, I just want to combine like terms. So I'm going to subtract 6x squared on both sides. Again, I like to move the smaller coefficients over so I don't have to deal with negatives. And then I think what I'm going to actually do to set this equal to 0, since it looks like it's going to be a quadratic, go ahead and move this 12x over as well by subtracting it. Because we know to solve quadratics, it needs to be set equal to 0 before we can like try to factor it and stuff. 7x squared minus 6x squared gives me my 1x squared. And then negative 35x minus 12x gives me negative 47x. And then always try to factor if you can, but if not, you can always go down to the quadratic formula or even complete in the square. Here, I'm going to look for a greatest common factor. And I notice they both have an x in common. And when I see that, I can then set these two factors equal to 0. So I get x equals 0 and x minus 47 equals 0. So therefore, x equals positive 47. Now, what happens here, you have to watch out, is you also have to figure out what can x not equal. And x cannot equal anything that's going to make the denominator 0. So the best thing to do is to take your factors here, set them equal to 0 to figure out what x cannot be. And in both situations, x cannot be 0. Because if I let x be 0, I would get 0 in the denominator, which cannot happen. All right, so that must mean that x equals 47. And then you can check it even further. 47 minus 5 is 42. And then 6 times 47 there. And then this is going to be 49 divided by whatever 7 times 42 is. And then those will give you the same conclusion. Just so that we are aware, let's just try that out. So 47 minus 5 is 42. 6 times 47 is 282. So 42 divided by 282 is 0.1489, whatever that is. 47 plus 2 would give you 49. And so therefore, 7 times 47 is 329. So 49 divided by 329 is still 0.1489, whatever. So you can see that even plug it in to check it, x equals 47. Now, because I came up with this question, it ended up being a nice, pretty number. But you'll probably end up with more prettier numbers with the actual examples. All right, let's do another example. This again is just going to be called example 2. And it is 5x over x plus 4 equals 6x over x plus 3. So in a situation like this, notice they both have a binomial. This still kind of goes to that cross multiplication. But again, I want you to note that the least common denominator here was x plus 4 and x plus 3. So I would multiply both sides by this. Again, I do realize that you could just simply cross multiply, but you're going to need to understand what's going on here so that when we end up with 3 fractions, you're multiplying by said denominators. All right, and when you do that, the x plus 4 will cancel. So I really have 5x times x plus 3. X plus 3 will cancel here. And I really have 6x times x plus 4 here. So 5x times x is 5x squared. 5x times 3 is 15x. 6x times x is 6x squared. And 6x times 4 is 24x. Again, I'm just going to move, so I don't want to deal with negatives, but I also want to set it equal to 0. So I'm actually going to subtract 5x squared on both sides and move everything to the right. Again, I do know it's a quadratic and it needs to be set equal to 0. And again, at the same time, I don't want my leading term to have a negative. Doesn't matter if it does, but it just makes life easier if it doesn't. And then 24 minus 15, that would give me positive 9x. Again, I see that there is a greatest common factor here. So I have x and then x plus 9. So I'll set my two factors equal to 0. Therefore, this one's x equals negative 9. And again, I come over here and I figure out what can x not be. So x cannot be a negative 4, and x cannot be a negative 3. So if x was negative 4 or negative 3, one of these values would be 0 as the denominator. In our situation, neither one of these is negative 4 or negative 3. So both 0 and negative 9 are acceptable answers. Let's try another example. Let's look at we'll call this example 3. So this is 8 over y minus 4 minus 9 over y plus 3 equal to 1. So there's another one in the book that I'm going to pull as well. But again, notice now we have 3 rational fractions because technically a whole number can always be a fraction by putting it over 1. So when I look at my least common denominator, I have y minus 4 and y plus 3. So therefore, I would multiply the entire equation by y minus 4 and y plus 3 to everything. But this time, just like before, when you were cross multiplying, you had to do it to both sides. You have to do it to every term. So again, I'm going to write this out so that you can see what's happening, but then I need you to see it on the next one. All right, so this one here is 8 times y minus 4 times y plus 3 over y minus 4 minus 9 times y minus 4 times y plus 3 over y plus 3 equals y minus 4 times y plus 3. There is no fraction there, so 1 times this is just this. But now notice the y minus 4's cancel and the y plus 3's cancel. So then I'm really left with 8 times y plus 3 minus 9 times y minus 4 times y minus 4 times y plus 3. So what I want you to see is when I distribute, this y minus 4 would cancel, and this y plus 3 would cancel, and I'd literally just be multiplied by y plus 3 and y minus 4 for these two guys, and then this one would get the entire thing. This would get y minus 4, y plus 3. So I need you to see that to make yourself, save yourself a step here so that you can go from here to here. However, if you don't and you need to write it out, by all means, write it out. All right, so then from here, I now have a regular quadratic equation going on here. So I just got to get rid of the parentheses. So 8 times y is 8y. 8 times 3 is 24. Negative 9 times y would give you negative 9y. Negative 9 times negative 4 would give you a positive 36. And then when I fold this out, y times y is y squared. Y times 3 is 3y. Negative 4 times y is negative 4y. And negative 4 times 3 is negative 12. I'm going to combine like terms on each side and then try to get them all to one side. So I see 8 minus 9y gives me negative y. And then 24 plus 36 gives me 60. So, yep. And then here I have y squared, and then 3y minus 4y gives me negative y minus 12. Again, I see I deal with a quadratic, so I'm going to move everything to the square term so that I can set it equal to 0. So that's going to be a plus y and a minus 60. This actually will cancel too, so let me work my work over here. So I now have 0 equals y squared minus 72. So then I'll add 72 on both sides. And then I would take the square root of it. Don't forget the plus or minus and then simplify. So I got 3 and 36. So that's 6 and 6. So I have plus or minus 6 square root of 3 is what my y is. All right. And again, you'd come over here and verify that y cannot be 4 and y cannot be negative 3. And that plus or minus 6 square root of 3 is definitely not that. Alrighty. All right, so those are my examples I wanted to kind of give you. They're a little bit easier than what the book gives you. So let's go into more complicated ones. So let's do one like that again. So this will be on page 138, and I want to do number 3. So this is 3 over x minus 2 plus 2 over x plus 1 equals 1. So again, notice that the least common denominator, again, is x minus 2 and x plus 1. So I will multiply everything by the two denominators. So the x minus 2 will cancel, and I really just have x plus 1. The x plus 1 will cancel. I really have just x minus 2. And the 1 will be multiplied by both x minus 2 and x plus 1. So therefore, I have 3 times x plus 1 plus 2 times x minus 2 equals x minus 2 times x plus 1. So I distribute to get rid of parentheses. So that's 3x plus 3 plus 2x minus 4 equals. FOIL this out. So it's going to be x squared plus x minus 2x minus 2. Combine like terms. So that gives me 5x minus 1. And then x squared minus x minus 2. Again, I see it's quadratic, so I want to set it equal to 0 by moving everything over. So that's going to be a minus 5x plus 1. minus 5x plus 1. Again, lining up your terms to keep everything organized. So I get 0 equals x squared minus 6x minus 1. So a quadratic will always factor into two binomials where the leading term is an x. And we just got to figure out what multiplies to -1 adds to -6. And in this situation, nothing, because the only way to multiply to a -1 is 1 and 1. So that means this is non-factorable. So the quadratic equation will then be coming into play. So that means that my A is 1, B is -6, and C is -1. Recall that the quadratic formula is -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this example, this will be -6 plus or minus the square root of -6 squared minus 4 times 1 times -1 over 2 times 1. So I get positive 6 plus or minus 36 plus 4, it looks like. Yep, over 2. And then I get 6 plus or minus square root of 40 over 2. 40 breaks up into 2 and 20, 2 and 10. There's two 2's there. So I get 6 is plus or minus 2 square roots of 10 over 2. Simplify both sides, so I now get 3 plus or minus square root of 10. Again, verify what can x not be. So x cannot be 2 and x cannot be -1. Well, 3 plus or minus square root of 10 is neither one of those answers. So there's your final answer. All right. So again, let's take this one more step further. So let's look at number 4. So I get x over x minus 1 plus 2 over x minus 3 equals -2 over x squared minus 4x plus 3. Now, a lot of times they make this nice, but you always got to check just in case. So what you want to do first is these are linear factors, can't go any further, but you do want to factor every denominator. So then a quadratic factors into two binomials where the leading factor is, or leading term is x. Then ask yourself what multiplies to 3, adds to -4. Use this as a guide because if they're nice to you, it'll be these exact things. So in this case, that would be -1 minus 3, which does multiply to positive 3 and add up to -4. So if they're nice to you, it'll be the other denominators. Sometimes they are not. When they do that, then your least common denominator will simply just be that x minus 1 and x minus 3. So now when I go through and I multiply all this, watch what happens. Again, we're going to multiply to everything. X minus 1 cancels, so I really just have x minus 3. X minus 3 cancels, I really just have x minus 1. But realize here that the x minus 1 and x minus 3 would cancel, and I'd be left with just -2. So I now have x times x minus 3 plus 2 times x minus 1 equals -2. So it made it a lot easier and cleaner to deal with. And then we can just go through and solve this quadratic. So x times x is x squared. X times -3 is -3x. 2 times x is 2x. And 2 times -1 is -2. After this point, combine like terms. So I get x squared minus x minus 2 equals -2. Now set it equal to 0. So now I'm going to add 2 on both sides. So I get 0 equals x squared minus x. And then now I will do greatest common factor. So I'll factor out an x, and I'm left with x minus 1. Set those factors equal to 0. So I get x equals 0 and x minus 1 equals 0, which is just x equals 1. But verify over here, x cannot be 1 and x cannot be 3. So I have to discard the 1, and now x equals 0 is my only answer. So definitely make sure you're checking to see what x cannot be so that you don't actually type in the wrong numbers. All right, let's do one more, and then we'll get into those word problems. There's quite a bit on y'all's homework. So let's look at number 7. So we have y over y minus 1 plus 2 over y minus 3 equals y squared over y squared minus 4y plus 3. All right, so again, we start off by factoring. So a quadratic will always factor into two binomials if it's factorable. The leading term is y. Ask yourselves what multiplies 3 but adds up to -4. In this case, it is -1 and -3. So again, they were nice to us. So therefore, my least common denominator would be y minus 1 and y minus 3. Take that entire thing. Y minus 1 would cancel, and you're left with y minus 3. Y minus 3 would cancel, and you'd be left with y minus 1. Both of these would cancel, and I'm left with just y squared. So now I have y times y minus 3 plus 2 times y minus 1 equals y squared. So this is about as complicated as you'll see on your test and homework. So it does get more in depth than that, but that's about as far as you'll have to go. So now what I'll do is I'm going to get rid of these parentheses by distributing. So y times y is y squared. Y times -3 is -3y plus 2y minus 2 equals y squared. Combine like terms, so I get y squared minus y minus 2 equals y squared. And then again, I see it's a quadratic, so I need to set it equal to 0. But when I subtract y squared on both sides, I'm now left with -y minus 2 equals 0. So then I get -y equals +2. Therefore, y equals -2. Check to see what x cannot be, or sorry, in this case, y. Y cannot be 1, and y cannot be 3. So in this case, y equal to -2 is your only answer. All right, so again, this is about as complicated as it gets when it comes to just solving rational equations. And then there is quite a bit of word problems, but they're all pretty much set up the same way. So let's work through quite a bit of them to make sure you have plenty of examples. So let's look at number 17. So on 17, it says, if Joanna were to paint her living room alone, it would take 5 hours. So to work this out, it's always going to be 1 over the first person. So in this case, this is Joanna. So Joanna, I don't know. But it'd be 1 over how long it takes her. In this case, it takes her 5. Her sister, Lisa, could do the job in 7 hours. So now we have Lisa who can do the job in 7 hours. So 1/7 of the time. How long would it take for them to finish working together? So this would be working together. So I'd add the 2 up, and it would equal 1 over x. We just don't know what that x is because we don't know how long it would take. So what we do is now you have a rational equation. So I got to figure out my least common denominator, which in this case is 5 times 7 times x, which is 35x. So I'm going to multiply everything by 35x. And so 5 goes into 35 7 times. So I really am multiplying by 7x. 7 goes into 35 5 times. So I'm really multiplying by 5x. X will cancel. So I'm really just multiplying by 35. So realize what parts can cancel by simplifying it. So I now have 7x plus 5x equals 35. And then you would add 12. Well, you would add the 2 and you would get 12x equals 35 and divide by 12. And it's so close to 3, but I don't know how close they want us to get. So you can leave it like this. So you can actually say 35 over 12 hours. Or if you wanted to break it into, it would be just about 2 hours. And it would be 11/12. Well, there's 60 minutes, so it's 5 minutes a piece. So that'd be 55 minutes. So you could go that route, but they accept this route as well. And that's it. So it's all about the setup, and it's pretty much the same. So let's do quite a bit more so you can see the setups even further. So in 18, it says the hot water tap can fill a given sink in 4 minutes. So hot water can do it in 1 out of 4. And this thing, the units is in minutes. If the cold water tap is turned on as well, the sink fills in 1 minute. So we have cold, but we know when they're working together, it can be done in 1 minute. So 1/1. How long would it take for the cold water tap to fill the sink alone? So now there's my mystery. I don't know how long it would take cold on its own to fill it up. If I know that hot would take 4 minutes and together it takes 1 minute. So there's kind of how you set it up. Least common denominator in this situation is just 4x because once is going to be times itself. So I'm going to multiply everything by 4x. So the 4 would cancel. I really just have x. The x would cancel. I really have 4. And this is technically just going to be just 1. So I'm going to multiply by 4x in itself. So 1 times x is x. 1 times 4 is 4. 1 times 4x is 4x. And now I'm just going to solve. So subtract x on both sides. 4 would equal 3x. And then divide by 3. So x would equal 4/3 minutes. All right. So again, it would take that, or you could write it as 1 minute. Thirds out of 60 is 20. So that'd be 1 minute and 20 seconds. So again, it takes this one, but you can write it as this as well. So if both of them are turned on, hot takes 4 minutes. Together, it's 1 minute. If cold was on by itself, it could do it in 1 minute and 20 seconds. All right. So again, you can see the setup was this again the same. Let's do another one. Let's look at 19. 19 says the hull of Jack's yacht needs to be cleaned. He can clean it by himself in 5 hours. So Jack can clean his whole yacht in 5 hours. But he asks his friend Thomas to help. Here's Thomas. If it takes 3 hours for the two men to clean the hull of the boat, so in this case it takes 3 hours, how long would it have taken Thomas alone? So there you go. Got the setup. Least common denominator would be 5 times 3 times x, which is just 15x. Take my 15x, multiply to everything. 5 goes into 15 3 times with the next. X cancels, so I just have 15. 3 goes into 15 5 times with an x. So I now get 3x plus 15 equals 5x. Subtract 2x on both sides. Again, I like to avoid negatives at all possible. 15 would equal 3x. And then I would just divide by 3. So I see x is 5. So was it hours? So it'd be 5 hours. So both Jack and Thomas can both do it in 5 hours. Is that the question? Hold on. How long would it have taken Thomas alone to do it? So let's see. It's book got 7.5 hours. All right. I must have did some math wrong. So I got Jack can do, hold on. Let's go back. So Jack, he can clean it by himself in 5 hours. Thomas helps. If it takes 3 hours for the two men to do it, that's 1/3. Doing the whole, how long would it take Thomas alone? So that's 1/x. So 5 times 3 is 15x. So that would be 3x. That'd be just regular 15. That'd be 5x. So you get 3x plus 15 equals 5x. Subtract, oh, there it is right there. You're probably going, I don't know why you subtracted by 2. All right. Again, sometimes my brain does this. So you subtract 3x, and the answer to that is 2x. So my brain had already done the math before I got to it. Then divide that by 2. And so therefore 2 goes into 15 7.5 times. So that'd be 7.5 hours. So if Thomas did it by himself, it would take 7.5 hours. All right. I knew there's some type of computation somewhere done wrong somewhere in there. All right, let's do another one. Let's look at number 20. 20 says 2 hoses, one of which has a flow rate 3 times the other. All right, so there's 2 hoses. We'll say first hose, second hose. In this situation, we have one hose that we don't know the speed of, and the other one has a speed of 3 times that amount. hold on, two hoses, one of which has a flow rate 3 times the other, can together fill a tank in 3 hours. So really, we'll say one hose is fast, and the second hose takes 3 times as long as the other hose. Um, I can't hold on. So it says of which has a flow rate 3 times the other. It's can together fill a tank in 3 hours. So together they can do this in 3 hours. How long does it take each of the hoses individually to fill the tank? And so we just come over here. And for your least common denominator in this situation, realize that you have x, 3x, and 3. So they have an x and a 3 in common. So your least common denominator would just be x. You could technically multiply by 9x squared. That would be a common denominator, but not the least common denominator. So I'm going to multiply everything by 3x. So the x will go away. I multiply by 3. 3x goes away completely. 3 goes away, and I'd multiply by x. So in this case, I have 3 plus 1 equals x. And so that's 4 equals x. So that means that the first hose, or the fast hose, can fill up this tank in 4 hours. The second hose, the slower hose, takes 3 times that amount. So it'd take it 12 hours to fill up the tank. And so there you go. Let's do another one. Again, make sure y'all have plenty of examples. Looking at 21 this time. 21 says officials begin to release water from a full man-made lake at a rate that would empty the lake in 12 weeks. So we're emptying the lake 1 out of 12. But there's a river that can fill the lake in 30 weeks. So we have something being filled. So if I have something that's emptying it and I have something that's filling it, I'm taking away from what I'm emptying it. So in this case, I will now have a subtraction and it'll be 1/30th. So if I have 1/12 being taken out, 1/30th of that 1/12 is now back into the lake, right? But a river, oh yeah, is replenishing the lake at the same time. How long does it take for the how long does it take to empty the lake? So in this case, I don't know how long it's going to take to completely empty it, but the fact that I got a river still flowing in it. All right, so here we go. So when I look at this, I look at the least common denominator and I see I got a 12, I got a 30, and I got an x. So let's do our prime factorization. So it's going to be 2 times 2 times 3, because 2 times 3 is 6, times 2 is 4. This would be 2 times 3 times 5. Because 3 times 5 is 15. 15 times 2 is 30. All right, so there we go. So we have 2 in common and a 3 in common. And then we still got a 2, a 5, and an x. So your least common denominator will be 2 times 2, which is 4, times 3, which is 12, times 5, which is 60. So my least common denominator will be 60x. Right? Now, yes, you could technically say that this would be, what is that? 360 as a 360x. You could multiply by that if you just multiply all those, but that would be a common denominator, not the least common denominator. So I'm going to multiply now everything by 60x. So 12 goes into 65 times with an x. 30 goes into 62 times with an x. And then, of course, x goes into 60x with just a 60 left. So I got 5x minus 2x equals 60. So that gives me 3x equals 60. Divide that by 3, and I can see that it would take the lake 20 weeks to completely empty with a flow rate out at one every at 12 weeks and a river being flowed in that would take 30 weeks to fill in. It would then take 20 total weeks for the lake to be completely drained. Let's do one more. Let's look at 24. After this, I think you'll have enough. All right, so it says a farmer can plow a given field in 2 hours. So we got a farmer. Less than it takes his son. All right, so we have a son. So if the son is this, the farmer can do that in less than 2 hours than whatever his son can do. So if they acquire two tractors and work together, they can plow the field in 5 hours. So how long does it take the father alone? And then it says round your answer. Okay, so our least common denominator here looks like it's going to be all of it. So it's going to be x minus 2, and I'm just going to go combine that as 5x. So here we go. So x minus 2 times 5x to every single thing. That would cancel. I'm left with just 5x. This would cancel. I'd be left with 5 times x minus 2. This would cancel. I'd be left with x times x minus 2. So here I have 5x plus 5 times x minus 2 equals x times x minus 2. Distribute. Get rid of those parentheses. So that'd be 5x plus 5x minus 10, x squared minus 2x. So in this case, combine like terms. So that's 10x minus 10 equals x squared minus 2x. I see it's a quadratic, so I'm going to move everything over. So that's minus 10x plus 10 plus 10. And I'll get 0 equals x squared minus 12x plus 10. So a quadratic factors into two binomials where the leading term is x. Two things that multiply to 10 but add up to negative 12. Well, the only thing I got in my brain is 1 and 10, which is 11, and 2 and 5. So this is non-factorable. I see now why they said round your answer. You have to use the quadratic formula. So A equals 1, B equals negative 12, and C equals 10. So remember the quadratic formula is negative B plus or minus the square root of B squared minus 4AC all divided by 2A. So this would be negative 12 plus or minus the square root of negative 12 squared minus 4 times 1 times 10 divided by 2 times 1. Two negatives make a positive. Negative 12 squared is 144. 4 times 10, so that'd be negative 40 over 2. And now I get 12 plus or minus the square root of 104 divided by 2. So it did tell us to round, so I'm going to do some math here, and I'm going to say this is 12 plus the square root of 104 divided by 2, and 12 minus 104 divided by 2. Let's see what we get. So I'm going to start off with 104. Take the square root of that answer, and then add 12 to that. Divide it by 2, and I get 11. What's round to what? Round your answer to one decimal place. So that'd be 11.1. This other one, I need to do 12 minus, let's see if I have to do 104 first and then square root. Yeah, so 12 minus the square root of 104. Give me that. Now divide that by 2, and I get 0.9. Okay, so here's the kicker here. So we know that x can't be 2 and it can't be 0, which is not something that we deal with. When you go back and you try to realistically answer this question, you can say, maybe you think the answer is 0.9, but 0.9 minus 2, because you're trying to figure out the farmer's time, would give you a negative answer, technically negative 1.1. You can't have negative time. So in this real life situation, even though it gives you an answer, a real answer, doesn't give you a realistic answer. So 0.9 is out the door. Using the other one, 11.1, because again, the farmer was x minus 2. 11.1 minus 2, I see that that would give me 9.9. That's a realistic answer. So not 9.9, sorry, a 9.1. So that would give me a realistic answer. So if the father did this alone, it would take him 9.1 hours, because that's what it's specifically asking for the father. which then tells me that the sun could do it in 11.1 hours. But together, they're able to do it in 5 hours. All right, so again, all of those word problems, yes, there's quite a bit of them, but they're all set up the same way. But as always, if you need more examples or more help, please reach out by email. Other than that, I will see you in the next video. Bye for now.